the blood clot. Does everybody see that? Not asking you to know every one of these factors. You do need to know people are insufficient or they are inactive. And if they are, this process does not occur. A process that is necessary for maintaining life. Now, in this process, as a whole, working to achieve this blood clot, how long do you think the process takes?
A few minutes.
Seconds. If your blood does not begin to clot in roughly 40 to 45 seconds, something is wrong. Under bigger circumstances, it will take a little bit longer, but under normal, everyday conditions, this should occur within 40 to 45 seconds. If it doesn't, they actually can test it. It's called a thrombin test, PTT test, or thrombin test. They test the time it takes for the blood to clot. And then they can begin to determine at what point could something be wrong. Could the person be deficient, for example, in calcium, which is very important? Could there be an inactive factor? So this is extremely clinically significant. I mean, think about it. If somebody is hurt, they really need to heal. So here's the cool thing. Once we begin to get these factors in motion, these little proteins, a lot of them, these factors, produced by the liver, they fly around in the plasma in their inactive form, meaning they're present, but they have to wait till they get activated. Once we have one get activated, it begins to set off this pathway. This pathway is called a reaction cascade, because as we begin to activate one, as they continue to get activated, they increase in number. This one being the common factor in both pathways. If we get to this and it gets activated and we activate that formation of the fibers, it will produce millions of the molecules necessary for the fibers. In the grand scheme of things, we have to make sure the blood clots dissolve. Like I said, platelets have the ability to do that. They secrete factors that help promote mitosis of tissues so that repair begins to occur. Fibroblasts actually invade the clot so that they can go in, start creating fibers, and begin to support the broken vessel. As the clot begins to dissolve, kallikrein, okay, this is important to break down the clot. So this is something else that becomes clinically significant. Our body, under normal conditions, when there's not any problems, has a way to keep all of these parts from clotting. And it goes back to how the vessel itself is lined by prostacyclin, because that basically repels platelets. We're able in the blood to dilute thrombin, which means it activates the fibrinogen. We also have, from the basophils, heparin, which is an anticoagulant. So this is how the body would basically go about stopping clotting from occurring at inappropriate times. That finishes 18. We'll start 19 on Tuesday.